Okay, to find the potential, we need to first draw a picture. So our charges are located at the origin, so this is going to be, call this one Q1, and the other charge is at point 0,3, so that would be 0,3 would be here, that's going to be Q2. And we're looking to find the potential at point 40, so we're going to put that here, and we're going to call that point P. So to find the potential at point P, phi of P, so remember that potential is a scalar, so we don't have to worry about the vectors. So phi P is going to equal phi 1 plus phi 2. And phi, let's see, so phi equals KQ over R, just over R. Okay, so we need to find R. So phi 1 is going to equal KQ over R, and R is the distance from vector 1 to P. Okay, so that's, just erase that. So from 1 to P, this distance right here, or I'm sorry, this distance right here, from 1 to P, this is going to be RP1. And I can see that this distance here is going to be 4. So this is, right here, this is 4. So for phi 1, I'm going to have KQ over 4. And for phi 2, I'm going to have KQ, Q. Okay, over KQ over RP2. And so that's going to equal K. So the first one's going to be KQ, we'll call this KQ1, and we'll call this one KQ2. So KQ2 over, and now RP2, that's going to be this vector right here. And so how do I figure this out? I know that the distance from the origin to Q2 is 3. So this looks like this is a triangle, and I know this is a 3, 4, 5 right triangle, but let's just say I didn't know that was a 3, 4, 5 right triangle. I would say that RP2, so that's RP2 is the vector from 2 to P. That's going to equal the square root of 4 squared plus 3 squared. And when I work that out, I get that's equal to the square root of 25, which is equal to 5. So I know this is going to be over 5. So now if I want to put them together, so phi 1 equals K, and now Q1 is equal to, go up for a second. So Q1 is equal to a negative 2 microcoulombs. Okay, so I'm going to have negative, let's just call this Q1 for now. Over 4 plus KQ2 over 5. Okay, and now I can factor k's out of both of these. So that's going to be k times, now Q1, well, I'll just write it Q1 over 4 plus Q2 over 5. So phi 1, or this is not phi 1 anymore, this is just phi p. So this is phi 1, this one's phi 1, and this one's phi 2. So phi p equals, now k is going to equal, this is 1, k equals 9 times 10 to the 9th Newton meter squared per Coulomb squared. And my q, this one is negative 2 times 10 to the minus 6 coulombs divided by 4 plus 3 times 10 to the minus 6 coulombs divided by 5. Okay, if I continue, so I have phi p is equal to 9 times 10 to the 9th Newton meter squared per Coulomb squared. And then if I divide, 2 divided by 4 is a half. So I'm going to say negative 0.5 times 10 to the minus 6 coulombs plus, and if I divide 3 by 5, that's 6, that's like 6/10. So this is going to be 0.6 times 10 to the minus 6 coulombs. So I get phi p is equal to 9 times 10 to the 9th Newton meter squared per Coulomb squared. And now negative 0.5 times 10 to the negative 6 plus 0.6, I'm going to get 0.1. So since 10 to the minus 6 is the same, I can add these together and I get 0.1 times 10 to the minus 6 coulombs. And so phi p, when I multiply 9 times 10 to the 9th times 0.1 times 10 to the minus 6, I get 900. And so now I'm going to get, I get 1 Coulomb canceled, so I get Newton meter squared per Coulomb. Oh, and I forgot my units here. So I have, this is a meter here, this is a meter, this is a meter, this is a meter, meter here, meter here. So this should be Coulomb per meter, Coulomb per meter. I knew I was missing a unit there. I have a meter here, so one of my meters gets canceled here, and I'm left with, let's see if I, okay, so I'm left with 900 Newton meters per Coulomb, and so a Newton meter is a joule per cool, and a joule per cool is a volt. So I get equals a volt. So I get phi p equals 900 volts. To calculate the work, so this is part A. Why it's doing that. This is A. And part B, the work is equal to the potential energy final minus the potential energy initial. And so that's equal to, the final is would be phi times the charge, so phi p times the charge, and then minus potential energy initial, since it was at infinity, that's going to equal 0. So we just have 900 times fix that, times 4 times 10 to the minus 6 coulombs, and this is volts. And so we end up, that's equal to 3600 times 10 to the minus 6 volts times coulombs. And so if I think about my my units, a volt is a joule per cool, a joule per coulomb. And so my units here would be joule per cool times coulomb. So my this is just going to become a joule. That would be my unit of energy. And so I'm not sure, the number that he has there is 360 times 10 to the minus 3. That looks wrong to me. So I think it would be 360 times 10 to the minus 5, right? I can move over 1 and subtract 1 here if I were to move my decimal. But I think this is the correct answer for potential energy.